Okay, good afternoon. Fifth graders, we are going to work on finding the surface area. So your objective here is going to be finding the surface area of prisms, and we'll review a little bit about cylinders, but primarily we are going to be looking at prisms. So you'll want to write this down in your Cornell notes. Okay, we're going to start by looking at just area. So on this one, we have 4 figures, and we're going to talk about using the area. Now, when you're finding the area, what you're trying to do is you are trying to find the amount of space an entire thing covers. Remember, the other one is to find perimeter. Perimeter is just the outside, but area is to find the amount of space it covers in a 2-dimensional figure. And we're talking about 2-dimensional because we're talking about being flat. So if you think of area, you could kind of think of a candy bar. The area would just be the chocolate over the top. So if you're thinking of a Snickers bar, the area is just like if you unfolded the chocolate, how much chocolate is on it. It is not what is inside. It's just that flat area. Finding the area, remember there is a formula. And the formula for area is written as A equals either length times width, or you might see it written as a capital B, the capital B meaning the area of the base. So if you see a capital B, that means area of the base. And otherwise you might see it as length times height, or see it as width times height. And anyway, it's taking one side and multiplying it by the other side. So on this one, if we have a square of 5 by 5, to find the area, it's 5 times 5. So it's 25, and it's really important to do cm squared. When you are finding the area, you need to square your measurement. On this rectangle down here, it's a 4 by 6. So 6 times 4 equals 24 cm squared. On the triangle, it's 1/2 base times height because a triangle is half of a rectangle. So if we do 1/2 base times height, this right here is the height, and you always find basically the center of the base and go to the height. So 1/2, 3 times 4 would be 1/2 of 12. 1/2 of 12 equals 6. One quick thing on the triangle, on finding the area of a triangle. If you have a triangle like this, that shape like that, this would be your base, this right here. To find the height, you need to extend that out, and your height is that. Yes. Well, it's close as I can get right now. Huh? Well, that little guy is supposed to be straight down to there. Okay? So a little bit about area. Okay. Now we're going to look at 3-dimensional figures. When you talk about 3-dimensional, we are taking plane figures. We are connecting them at edges. So all these places, when you have a 3-dimensional figure and you are connecting them, those are called the edges. And we're taking something flat and we're making it take up 3 dimensions. The net is what happens when you take a 3-dimensional shape and you unfold it. Now in this case, it's like looking at a box. Okay, so we're looking at a box. And if you take each piece apart and you lay it flat, this is called its net. Okay, so when you undo it, it's called a net. So if we look at this one, it's the same thing. Each one of those different 2-dimensional shapes combined on an edge form a 3-dimensional shape. So if you think of a pizza box, it's the outside of the pizza. If you think of a cereal box, if you've ever undone the bottom and undone the top, and then you can take it apart, that's a net. That's the net of the pizza box. A milk carton is a combination of lots of shapes that when folded and bent, first of all, we get a prism, and then by a series of folds, you get the milk carton. And the same with a pyramid. Pyramid, because all the sides are Actually, that's not a pyramid. That's a prism. Because all the sides are triangles. When you fold it up, pyramids have square bottoms. Yes. Prisms. It's a triangular prism or a pyramid. Pyramids have square bases. So think of Egypt when you think of pyramids. They have square bases. They don't have... All right, so if we look at this, you see this shape is a three-dimensional shape. What you need to know to realize it's a three-dimensional shape is you can see these lines here, but you always have to remember that behind those lines is another side. And if you turn this shape around, it is going to take up more space than a flat shape would. Okay? To find the net of a three-dimensional shape, especially when it comes to a cube or a rectangular prism, you can have many different nets depending on how you unfold it. Okay? So you can see here, if you would cut on these lines and fold it flat, that would be a net for that. This could be a net for that. And so that's why the activity we're doing in the back is where you have to look at all those different arrangement of the rectangle or squares and figure out which one actually makes a cube. Because when you have a net and you see the net, these edges where they connect are folding lines. And these are not folding. You can't untake and put to another one. Okay? All right, so let's look at surface area. Surface area is measuring the surface of an object. So if you think of an orange, and when we eat an orange, you unpeel the orange, right? And you take the peeling off. If you were going to measure the surface area of the orange, you're going to measure the peeling, not what's inside, not the sections. That would be the volume of the orange. It's just like taking off the peeling. So if you took the peeling off an orange and you laid it flat, that would be the orange's net. Same with an apple. That'd be really hard to peel off. If you peeled off the outside of the apple, that would be the net. The inside is the volume. Yes? Yeah. Yep, when you find the surface area, there's two different ways you can find surface area. So if you look at this one, I took our rectangular prism, unfolded it, and if we were going to find the surface area, one way you can do it is you can treat each one of these rectangles individually. So let's say we took this one right there. What if we found the area of that? What would that area be? We'd count these. 1, 2, 3, 4, 5, 6, 7. There's 8 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if we found the area of that, what would we do? 8 times 11. So this one is 88. Now, one thing you can notice is these are not marked. When you don't have a marked unit, it's just called a unit. So it would be 88 units squared, or you could say cubes squared, or whatever you want to call it. Okay? This one would be 1, 2, 3, 4, 5, 6. So if we're measuring this one, and it's 11, we know that. So this area is 66 units squared. This one here is 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6. So this one would be 48, 6 times 8. This one here, we know it's 11, and we know it's 8 because these sides are parallel to each other and opposite, so they have to be identical. So this is 88. This would be 11 and 6, so this is, and this one has to match this one, so it's 48. So if we know the area of each individual rectangle, we know the surface area by doing what? Adding them all together. So we do 48 plus 66 plus 88 plus 66 plus 88 plus 48. And that would give us our area. All right, so let's look at this one. It says, understand it. The flat surfaces of a solid figure can be unfolded into a two-dimensional model. So a net is basically A two-dimensional model of a three-dimensional figure. The net is a two-dimensional model of a three-dimensional figure. The surface area of the solid figure is the sum of the areas of the flat surfaces. So when you find the area of one surface, you add them all together, and that's the surface area. So in this one, if we have Rufus wants to cover a shoebox with decorative paper to make a storage box for his photos, how much paper will he need to cover the box? So there's a couple ways we could find the surface area. One way would be draw the net. And can we draw a net based off of what we have here? Yes, because we know the height, we know the width, and we know the length. So we can figure out what each of those rectangles should be. If you don't want to draw the height, you could, or draw the net, you could also say, okay, this one right here is, I know it's an 8 by 6. So I know that's 48, and I know there's two of them. So I know that would be 96. So I have the front and the back covered. You could say, okay, this one right here is a 10 by 8. So this side right here is 10 by 8, which is 80. No, it's 10 by, oh, you're right. 6, 60. I know there's two of them, so I can times it by 2, so I know it's going to be 120. Okay? And then the top one, whoop, I got to put this down and pick it up, don't I? The top one I know is a 10 by 8. So this one's 10 by 8. I know that's 80. I know there's two, so I know there is 160 of those. I know.